For almost 100 years, our picture of the universe has felt solid. We have a story we tell ourselves about the cosmos, and it's a good one. It kicks off with the Big Bang, gets driven by gravity, and is held together by a mysterious, invisible glue we call dark matter. This whole story has a name, the Lambda CDM model, and honestly, it's been incredibly successful. It explains the cosmic web of galaxies, the afterglow of creation, pretty much the grand evolution of everything we see. It's the foundation of modern cosmology. But what if that foundation is starting to show some cracks? What if, out in the vast, quiet corners of space, things are lurking that just don't fit the story we've been telling? In recent years, a series of baffling discoveries have started to pick at that foundation, one thread at a time. Astronomers, pointing their best telescopes at patches of sky they thought were empty, are finding things that our current rulebook says shouldn't be there. They're hearing whispers of structures so massive they defy easy explanation, and seeing collisions so violent they might just rewrite the laws of matter itself. At the heart of it all is a single, incredible discovery, a candidate for a true ghost galaxy, made almost entirely of dark matter. This isn't just about finding something new. This is about a wave of cosmic weirdness that's forcing us to question almost everything. This is the story of how we might have to rethink our entire understanding of the universe, and how the neat and tidy laws of physics might be about to get a whole lot messier. It all starts with a mystery named Cloud 9. For years, astronomers have had this fascinating idea about dark galaxies. And no, not just galaxies with a lot of dark matter. Pretty much every galaxy has that. These are supposed to be almost pure congregations of dark matter, massive halos of the invisible stuff that, for some reason, never manage to light up with stars. They're the theoretical fossils from the dawn of time that just never grew up. According to our leading model of the universe, Lambda CDM, these things should be everywhere. The model predicts that dark matter, which makes up about 85% of all matter, should clump into countless invisible halos. Most of them, especially the little ones, would never pull in enough regular gas to actually start making stars. They'd be invisible skeletons, populating the universe in their trillions, but forever hidden from us. Finding one wouldn't just be cool, it would be a monumental confirmation of our deepest theories. And recently, astronomers think they've finally found one. About 14 million light-years from Earth, near the stunning spiral galaxy Messier 94, they spotted a faint, lonely cloud of hydrogen gas. It was first seen as a smudge in radio surveys from the FAST telescope in China, and follow-ups with the Green Bank telescope and the Very Large Array confirmed something was there. But the real shock came from what the Hubble Space Telescope saw, or rather, didn't see: stars. There were none. Not a single one. This wasn't some dim dwarf galaxy. This was something else. This was Cloud 9, the strongest candidate yet for a true, failed galaxy. So why is a cloud with no stars such a big deal? To get it, you need to know the rulebook it seems to be breaking. The standard model of cosmology gives us a pretty clear recipe for building a galaxy. You start with a huge, invisible halo of cold dark matter. Think of it as a gravitational seed. Over millions of years, its gravity pulls in tons of hydrogen gas. As the gas falls in, it cools, gets super dense at the center, and eventually, boom. Pockets collapse, nuclear fusion ignites, and the first stars are born. A galaxy is born. This process is supposed to be almost automatic. If a dark matter halo gets massive enough, it should make a galaxy. The big question has always been, well, what is massive enough? Where's the dividing line? For decades, models suggested a tipping point. Below a certain mass, a halo's gravity would be too weak to hang onto its gas, especially back in the early universe when intense radiation from the first stars was blasting everything, and boiling away that precious fuel. Only the biggest halos could survive this. The little ones were doomed to stay dark. This theoretical ghost, a dark halo that held onto some gas but still failed to form stars, was even given a name, a real HIC, for reionization limited HI cloud. And Cloud 9 looks like it could be the first real one we've ever seen. When radio telescopes looked at Cloud 9, they found a core of hydrogen gas stretching a few thousand light-years across, with the mass of maybe 1 million suns. That sounds like a lot, but it's peanuts for a galaxy. What was truly staggering was the dark matter holding it together. By watching how the gas moved, the team estimated the invisible halo weighed something like 5 billion solar masses. This thing is almost entirely dark matter. And this is what makes it so profound. The estimated mass of Cloud 9's dark matter halo sits right on that critical edge, predicted by the Lambda CDM model. Its gravity was just strong enough to cling to a bit of hydrogen gas during that violent early era, but it fell just short of the threshold needed to kickstart star formation. It is, in every sense, a failure, and as the astronomers on the project explained, this failure is a huge success for science. While countless dark halos are predicted to exist, most should have lost all their gas, making them totally invisible. Cloud 9 is special because it's massive enough to have held on to just enough gas to be spotted by our radio telescopes. It's some of the first direct evidence for this fundamental prediction. The Hubble Space Telescope delivered the final knockout punch. Before Hubble, you could have argued Cloud 9 was just an incredibly faint galaxy. But Hubble stared deep into the cloud's heart and saw nothing, just the faint smudges of distant background galaxies millions of light-years behind it. The absence of evidence was the evidence. One of the theorists behind the Relhic idea, Alejandro Benitez Lambé, has noted that in science, you often learn more from failures. In this case, seeing no stars is what helps prove the theory right. It tells us we found a primordial building block of a galaxy, right here in the modern universe. Cloud 9 is a cosmic ghost, a snapshot of the raw materials for a galaxy, seemingly frozen in time. It validates a decades-old prediction, but in doing so, it also cracks open a Pandora's box. If Cloud 9 is real, it means the universe is secretly swarming with trillions of similar, smaller dark objects. Our cosmic census has been missing most of the population, and Cloud 9 was just the first piece of a much larger puzzle that has been coming together. It primed us to look for the weird stuff, and the universe did not disappoint. Just as everyone was trying to figure out what a starless galaxy meant, other strange discoveries were piling up. Take the Champagne Cluster. Okay, so that's not a real nickname you'll find in a journal, not yet anyway, but it represents a very real type of cosmic event that's giving us headaches: colliding galaxy clusters. These are among the most violent things the universe can cook up. Hundreds of galaxies, each with a supermassive black hole, all smashing together over hundreds of millions of years. What makes these collisions the perfect physics labs is how they separate everything. A cluster is made of 3 things: galaxies, a ton of hot gas floating between them, and an even more enormous amount of dark matter. When 2 clusters collide, the galaxies and the dark matter are expected to pass right through each other like ghosts, because they only really interact through gravity. But the rot gas? It's different. It slams into the other gas like 2 waves crashing, creating a massive shock wave that gets left behind. This creates a spectacular separation. The galaxies and dark matter sail on, while the normal matter lags behind. We saw this beautifully in the Bullet Cluster, which gave us some of the best proof for dark matter's existence. But some newer, messier collisions, like the megacluster known as El Gordo, have shown hints that dark matter might not be so ghostly after all. The standard model says dark matter particles are completely aloof, but an alternative idea, self-interacting dark matter, or SITM, suggests they can actually bump into each other. If that's true, the dark matter halo would get slightly slowed down by its own internal friction during a collision, creating a tiny but measurable offset from the galaxies. The data from El Gordo and other clusters are being used to place limits on this idea, and while it hasn't proven Sidham is correct, it's a tantalizing possibility. A new force of nature, acting only in the dark. It would fundamentally change the identity of 85% of the matter in the universe. But the weirdness didn't stop there. Recent years have also brought one of the strangest and most beautiful mysteries into focus: odd radio circles, or ORC. First found in 2019, they're gigantic, faint rings of radio waves floating in deep space, often 10 times bigger than our entire galaxy, but totally invisible in other kinds of light. And at the center of each one, there's a galaxy. What on earth are they? For a while, it was a total enigma. Were they shockwaves from merging supermassive black holes, the remnants of a galaxy-sized explosion? More recent discoveries and simulations are pointing towards a wild explanation. They might be the smoke rings from colossal, super winds. The idea is that a massive burst of star formation in the central galaxy could drive a phenomenal wind for hundreds of millions of years, inflating a titanic bubble. Then, the wind dies down, but the shockwave keeps expanding for a billion years, its edges still glowing faintly in radio light for us to find. While this is a plausible model, it shows just how extreme these events have to be. They tell us that galaxies are having a much more violent and far-reaching impact on their surroundings than we ever knew. And the hits just kept coming. Astronomers found SPT 234956, a protocluster of over a dozen galaxies all furiously forming stars just 4 billion years after the Big Bang. The sheer density of this thing challenges our models for how quickly such massive structures could have possibly gotten together. We've also confirmed more interstellar visitors, like the Comet 2 I/Borisov, precious samples of rock and ice from entirely different star systems. Each of these is a fascinating puzzle, but together they paint a startling picture. Cloud 9 suggests a hidden population of dark objects. Cluster collisions hint that dark matter might not be so simple. ORCs show that galactic events are more powerful than we imagined. And early protoclusters suggest the cosmic construction timeline is all wrong. It feels less like we're filling in gaps in our knowledge and more like the whole frame is starting to bend. The universe we're observing today is proving to be far more complex and dynamic than the one in our textbooks. The story we've been telling ourselves is starting to sound like a fable, and a new, more chaotic reality is emerging from the dark. And this is where it all gets really exciting. We are living in a golden age of cosmology, where every new observation could be the one that rewrites the story of everything. The sheer amount of data coming in is forcing us to face these huge questions. If you find this journey to the edge of what we know as thrilling as I do, think about subscribing. We break down the latest discoveries every week, from ghost galaxies to the mysteries of dark energy. Hit that subscribe button and turn on notifications so you don't miss the next chapter. Your support helps us keep exploring these paradigm-shifting ideas and bring the universe a little closer to home. So, what do you do when the universe won't play by your rules? When new observations keep poking holes in your most successful theory? That's the spot cosmologists are in right now. The Lambda CDM model, for all its glory, is facing some serious tensions. The strange things we've been finding aren't just isolated curiosities. They could be symptoms of a deeper issue. Let's start with dark matter. Finding a great candidate for a failed galaxy like Cloud 9 does two things at once. First, it beautifully confirms a key prediction of the cold dark matter model. It's a huge win. But that win comes with a scary consequence. By showing that these dark, gassy halos can exist, it proves our telescopes have been blind to a whole class of objects. The universe we see, the one made of bright stars, might just be the tip of a cosmic iceberg. Then there's the nature of dark matter itself. The cold dark matter model is simple. The particles are slow-moving and only interact through gravity. Cosmic ghosts. But the weird behavior hinted at in cluster collisions challenges this. The self-interacting dark matter model offers an exciting alternative. It suggests dark matter has its own rich, internal physics, that dark particles can bounce off each other. This would mean there's a new, dark force of nature we've never seen. The implications are staggering. There could be dark photons or other force carriers. The invisible universe could be just as complex as the one we see. A colliding cluster isn't just a crash of galaxies, it's a particle accelerator the size of 1,000,000 galaxies, and its results might be telling us our standard model of particle physics is incomplete. These discoveries are also forcing some to ask a more radical question. Is our theory of gravity wrong? For a century, we've relied on Einstein's general relativity, but theories like modified Newtonian dynamics, or MOND, propose that gravity works differently on galactic scales. For a long time, MOND couldn't explain things like the bullet cluster, but the theory is always evolving. Or what if the accelerating expansion of the universe, which we blame on dark energy, is just an illusion? Some provocative, though still fringe, models suggest that time itself might flow at different rates in different parts of the cosmos. Clocks in dense regions might tick slower than clocks in empty voids. What we see as a universal acceleration could just be an averaging effect of living in a lumpy universe. This idea challenges the most fundamental assumption in cosmology, the cosmological principle, which says the universe is the same in all directions. And even that is now being tested. Some recent studies of the cosmic microwave background and distant galaxies have hinted at a strange alignment, a cosmic dipole, suggesting the universe might be a bit lopsided. This is highly controversial, but if it holds up, it could shake the very foundations of our models. This is the precipice we're on. Do we invent new particles to save the framework? Do we change the laws of gravity? Or do we give up our most cherished assumptions? These new discoveries aren't just adding pages to the textbook. They're forcing us to wonder if we need to write a whole new book. Science isn't about having all the answers. It's about being brave enough to question the answers you thought you had. And right now, the universe is asking some very hard questions. What a time to be alive. For generations, we looked up at the sky and saw a universe of elegant, predictable clockwork. But recent discoveries have started to challenge that illusion. They've shown us a cosmos that is wilder, more chaotic, and infinitely more mysterious than we dared to imagine. The discovery of a potential, failed galaxy like Cloud 9 is incredible. It seems to prove a key prediction of our best theory, while simultaneously showing us how incomplete that theory might be. It tells us we are surrounded by a hidden population of dark matter skeletons, cosmic relics that could number in the trillions. We thought we were studying the forest, but we may have only been looking at the tallest trees. At the same time, violent cosmic collisions are challenging the identity of dark matter itself, hinting that it's not a passive ghost, but a dynamic entity with its own complex forces. And colossal structures like odd radio circles and super-early protoclusters are forcing us to rethink the timeline of cosmic evolution itself. Together, these anomalies signal more than just a few tweaks. They could be pointing towards a genuine paradigm shift, maybe as profound as the revolutions of Copernicus or Einstein. The Lambda CDM model, which has served us so well, might not be the final word. It might just be a brilliant, but ultimately incomplete, approximation of a far richer reality. What comes next? The future lies with the next generation of observatories. Telescopes like the Square Kilometre Array will map faint hydrogen gas across the sky, potentially uncovering thousands more objects like Cloud 9. The Vera Rubin Observatory is conducting a massive survey of the sky that will help us map dark matter with breathtaking precision. And missions that are already operating, like the Euclid Space Telescope, are designed specifically to probe these great mysteries. These instruments won't just find answers, they'll uncover questions we haven't even thought to ask yet. That is the beauty of science. With every circle of light we draw, the circumference of darkness grows. The universe doesn't owe us simplicity. Its only obligation is to be what it is. Our obligation is to keep looking, keep questioning, and have the humility to admit when our story needs to change. These discoveries are not an ending. They are a beginning. They are an invitation from the cosmos, telling us that the greatest adventure of all, the quest to truly understand our place in the universe, is far from over. In fact, it may have only just begun.